What is everything made of? If you could zoom in on your hand, a rock, or a glass of water, what would you see? This question has fascinated humans for millennia. In ancient Greece, Democritus imagined that if you kept cutting matter into smaller pieces, you'd eventually reach something uncuttable, an atomos. For centuries, this was just a philosophical guess with no evidence to back it up. Fast forward to the 1800s, John Dalton, studying chemical reactions, noticed elements always combined in fixed ratios. Dalton realized this only made sense if matter was made of tiny, indivisible particles, atoms. He proposed that all matter is made of atoms, identical for each element, and that chemical reactions are just rearrangements of these atoms. This was the birth of atomic theory, turning philosophy into testable science. Dalton's ideas laid the foundation for modern chemistry. The quest to understand what everything is made of had finally moved from speculation to proof. And with that, the real detective story of the atom began. Science. For a while, atoms were thought to be solid, indivisible spheres, but in the late 1800s, J.J. Thomson's experiments with cathode ray tubes changed everything. He discovered that the mysterious rays were actually tiny, negatively charged particles, electrons, almost 2,000 times lighter than hydrogen. The atom wasn't indivisible after all. To explain this, Thomson proposed the plum pudding model, a sphere of positive charge with electrons scattered inside, like raisins in a pudding. This model explained the atom's neutrality and was a huge leap forward. But science never stands still. The discovery of the electron shattered the old view and opened up a new mystery. What else was inside the atom? The search for the atom's true structure was just beginning. The next breakthrough was right around the corner. The atom was about to get even stranger. The detective story continued. Science! Enter Ernest Rutherford, who set out to test the plum pudding model with his famous gold foil experiment. He fired alpha particles at thin gold foil, expecting them to pass straight through. Most did, but a few bounced back, as if hitting something dense and powerful. This was shocking. The atom couldn't be a diffuse cloud of charge. Rutherford realized the atom must have a tiny, dense, positively charged center, the nucleus. The rest of the atom was mostly empty space, with electrons orbiting far away. This nuclear model replaced the plum pudding idea and explained the experiment's results. In 1919, Rutherford identified the proton as the source of the nucleus's positive charge. The atom was now seen as a miniature solar system, a dense nucleus with electrons orbiting around it. Most of the atom was empty space. This discovery changed everything we thought we knew about matter. The atom's secrets were only beginning to unfold. Science. Rutherford's model raised a new puzzle. The nucleus's mass was greater than the total mass of its protons. Where was the extra mass coming from? In 1932, James Chadwick solved the mystery by discovering the neutron, a neutral particle with mass similar to a proton. The nucleus was now known to contain both protons and neutrons. But another question remained: why didn't electrons spiral into the nucleus? Niels Bohr proposed that electrons could only occupy specific energy levels or shells around the nucleus. They could jump between levels but not exist in between. This idea brought quantum theory into atomic structure. The atom was no longer just a miniature solar system. It was governed by strange quantum rules. The atomic model was coming into focus, but the mysteries weren't over. Each discovery led to new questions. The journey into the atom was far from finished. Science. Bohr's model explained why elements emit specific colors of light, but it couldn't handle more complex atoms. In the 1920s, scientists like Schrödinger and Heisenberg developed the quantum mechanical model. Electrons weren't in neat orbits. They existed in fuzzy clouds of probability called orbitals. We could only predict where an electron was likely to be, not its exact position. This model forms the basis of modern chemistry, electronics, and materials science. The story of the atom is a journey from ancient philosophy to cutting-edge quantum physics. Each discovery didn't just add a piece, it changed our view of reality. Today, physicists are searching for even smaller particles inside protons and neutrons. The quest to understand what everything is made of continues. Science is a never-ending story of curiosity and discovery. With every answer, new questions emerge. And that's what keeps us exploring.